opinions expressed in this article are those of the authors and do not necessarily reflect the opinions of my employer. Examples of analysts and code used within this presentation are only examples. They should not be utilized in the real-world products as they should be considered as based on limit and possibly dated open source information. Assumptions made within this presentation are not reflective of the position of any private or government entity to which the author is presently employed.
Hello everyone and welcome to my primer on Networks and Security Firewalls 101. Some of the things we're going to talk about today is what is a firewall? Where does the word firewall actually originate from? What is a firewall's main job? We're going to talk a little bit about remote access. You should know some of the terms like DMZ. I'm going to go through some configurations that are particularly bad and you want to avoid. And I just want to make a note that today's presentation is at a high level only. A lot of the technical details are being left out. The idea of this is to introduce somebody who doesn't know a lot about firewalls and terminology that security people use to help them better understand and better carry on a conversation. If you were to look at this at a high level detail, you would find problems and little technical errors, but that's not the goal today. The goal is just to give you an overview and some things to watch out for. So what is a firewall? So in the old days, we would kind of tell people that a firewall is kind of like if you have a castle, something that you want to protect the people in the castle, and you might build a moat around that castle, and we would call that the perimeter of your internal network. And that analogy is a little bit problematic today because where are the boundaries of the networks we use today? We use tools like Microsoft Office and OneDrive and Google and Gmail, and our network is all over the place. With cloud computing, checking your email is on servers that you don't even know where they're at or what they're doing. So the network is a bit expanded. So for the context of today's conversation, we're going to differentiate between data that you really want to protect, personal information or private information, and then the big bad internet. So where does this word firewall come from? Why do we even call it a firewall? So the original word of firewalls before computers was all about how you would protect a building when a fire occurred. And what's interesting is there's this building that I drive by quite frequently in my area. And if you notice in this picture of the building, there's these two spots here and another one over here where you can see that sort of the wall is coming a little bit higher on the side. And that's the actual original usage of a firewall. So let's say a fire would start, say, in this part of the building, or maybe a fire might start in this part of the building. The fire is unable to move through into this middle part of the building, or maybe the fire was in the middle part of the building and the fire is not able to move and damage other parts of the building. So it's protecting areas of the building. Kind of interesting as I walk by this building most days, this is actually a well-known branch of a well-known security company. I'll leave it to you to figure out who that is, but they actually do a lot of things protecting people on the internet, and they're actually in a building with a physical firewall. So I always think that's cool when I walk by. So what's the main job of a firewall? So let's say this is your home network, or maybe it's a company network, but this is some really secure stuff. You don't want people seeing the stuff that's here. And this we'll call the big bad internet. The hackers are in here. They're trying to attack machines. This is where all the web servers are, the Googles, everything like that. So what happens is, let's say you want to go to Google or go to Facebook. Your computer makes a request to one of the servers out there on the internet. That server then responds along that same path line back to your computer, and you can view the web page or check your email or whatever it is you want to do. Now, without any firewall, network can also travel in the opposite direction. So one of these bad computers or hackers, they can then make requests of your computer and say, hey, let me see the data that's on your computer. And your computer's like, sure, great. It goes back and it sends it. So at a high level, primarily what the firewall is doing is it's allowing these requests to go out. It's allowing the responses to come back, but it's stopping computers from over here from making requests to your own internal computers on your own internal network where your own private stuff is. What happens is when the data comes across and say, hey, can I talk to this computer? The firewall is a little bit like a cop. It's like, nah, nope, not going to get in. So that's how the firewall generally protects you. Now you can set rules up on what can be requested this way as well, but we're just talking about the main idea of the firewall is to prevent the data from going back from the internet, accessing your machines and getting at your data. So that's what the firewall is doing. So you may hear a term where a security person will make an exception in the firewall, or another word that you might get here used is that they will punch holes in the firewall. So while your data here can go out and access Facebook and return back your Facebook information, there are some cases where you want, let's say you're sitting in a coffee shop and your coffee shop is over here, it's on the internet, and you want to access some files that are on a computer over here on your network, and you're like, well, I need a hole to be punched through the firewall to be able to let me do that. So like I said, two main reasons that this would happen is you want to establish a virtual private network, or maybe you want to use some sort of tunneling protocol like secure shell or secure FTP to access those files. The key thing that happens here when we want to punch these holes is two important aspects. One, whatever computer is on this side, we want to authenticate. We want to make sure that it's the right user and we want to encrypt it. We want to make sure that the data when it's moving here can't be accessed by anybody except the person sending it and the person receiving it. So user authentication and end-to-end encryption of the data while it's in transit back. Now, because these are tunneling protocols, what that means is that it's effectively taking you in your coffee shop, your computer over here, and it's moving it so that it's just as if your computer was protected behind this firewall by tunneling through this sort of hole. Now, there's all kinds of other holes, other exceptions that can be made, but they're not such a good idea. So for example, you may have a webcam. You might have one of these installed in your house or in your place of work. They're taking pictures, they're watching videos. You wouldn't want to punch a hole from your webcam through to the internet because then somebody accessing hackers going into that webcam then have entire access to your full network and look at all your private files. Other examples are online gaming. So a great example of this is Minecraft. In Minecraft, you can do what's called opening up a server, which then allows multiple people to play together on the same game, and they share your computer over a port. So it's sort of putting this hole in your firewall to allow that incoming game to go in. Again, it's problematic because once you do that, you allow those external hackers to hack into that game or even get past that game and into your actual computer files that you want to protect. A big problem here is people using file sharing apps, ones like BitTorrent, or in the olden days, we had things like LimeWire and Kazaa. And even Windows has its own file sharing called SNB, which is sometimes known as Samba. But this then allows file sharing to go back and forth between the internet and your home computer. Again, opening up firewalls specifically for that purpose can be very risky indeed. Now remember, you may very well be in a coffee shop and want to look at your webcam. You may want to do some file sharing. You may want to do some online gaming, and that's all well and fine, but don't make the holes in your firewall specific for those applications. Use something like a VPN or a secure shell, which will then move your computer safely behind the firewall, as I've shown earlier. And then you can access those devices as if you were right in your own house. It will all be encrypted and it will all be authenticated that only the proper logged in users can do that. What about smart devices? I mean, we live in a world today where we have things like Google Home and Amazon Alexa and our smart clocks and our thermostats, and we can turn our lights off and on. They're a little bit of a special exception that I'll talk about a little bit later, but they do have the ability to allow you to control things in your house from outside in the big bad internet world. And again, I'll talk about a little bit about how that safety works later. Now, it wouldn't be a lesson around security and firewalls if I didn't talk about something known as universal plug and play, UPnP, particularly when it comes to networking. So UPnP was actually an interesting technology that's been developed that allows configuration to be easier for users. We could call it zero configuration. Great idea. You buy your device, you plug it into your network. Other computers on your network can automatically discover it. They can talk to one another. You don't have to go into any weird setup. You don't have to run any programs. They just automatically talk. So it's a neat idea. Where it becomes a little bit problematic is that UPnP can also be used to punch these holes in your firewall automatically. So you open up your game on your Xbox where you play Minecraft, and it automatically creates this hole in your firewall to allow access in. Now that's usually a feature that you can go into on a router and you can turn it off. Hopefully it's disabled by default, and that will prevent that sort of accidental ability for your game to open up ports to the internet when it really shouldn't. Now, extended from UPnP because of some of its problems and its vulnerabilities was the idea of DLNA. And that is a technology similar and somewhat uses UPnP, but the idea is it's very restricted to media sharing. So, for example, if you're on your downstairs television and your downstairs television can somehow magically see your upstairs set-top box that has all your media on it, it's doing that using a technology called DLNA. It's automatically finding each other, just like UPnP, has zero configuration, but it's limited to just the ability to transfer media back and forth. So it's kind of a smaller scope than what UPnP can do. Okay, now all is well and good, but suppose you do want to have your own web server and you want your web server to be accessible by people on the internet. Having it behind your firewall isn't really going to help that because nothing on the internet can send the data to your system, so nobody's ever going to be able to see all the cool web pages you put on your web server. So to do that, we have what's called a demilitarized zone. So what that means is we can designate a specific computer and we can say, okay, this specific computer, I want it to go outside the firewall. I want it to be out here. And I'm going to designate that my web server. So I'm going to put all my cool files that I want to share with people on that system. Now, the web server can talk to the internet. It can send requests. Hey, show me these pages on Google. But also, the internet can request pages from the web server. Oh, hey, I want to see, the videos of my kids or whatever it is I put up there to share. And all is well and good. They're stored on that web server. Remember, my network can still talk to the internet and anything out there on the internet, which includes that web server. So from my point of view, inside my private protected network here, I can still go out, I can see the internet, I can go to Google, but I can also go to the web server. All is well and good. Remember, the internet devices here, the hackers, because of the firewall, they cannot make any requests to my network, which also means this web server, which is on this side of the firewall, can also not make any requests to anything on this side, so it's secure. Even when you have a firewall, there's still a risk. We might call this an inherent risk to accessing the internet. And most people will often say this risk is ignored because it's considered unavoidable. You could choose not to go on the internet or not to connect your computer to the internet at all, and you would be 100% safe, but then you lose the fun and enjoyment of being on the internet. So there's this sort of little bit of an inherent risk. And a simple analogy to think of to keep this in your head is the analogy of safer sex. So if you think of a firewall as the condom, it doesn't prevent things from happening 100%. It's not 100% preventable. It does usually require the user to make some sort of mistake in order for your data to get compromised, in order for stuff in your network to get stolen. And that could be because you opened an email attachment that was unsafe, or you downloaded a software and that software contained a virus or it contained malware, or maybe you got tricked by a phishing attack, a fake looking email that said, hey, please go log into your Facebook site, but really wasn't Facebook. It just was made to look like Facebook so that it could capture your username and password. And there's some unsafe browsing practices, downloading files, enabling certain types of files to be executed without asking you. Sometimes there's holes in the actual browser application. There's like security vulnerabilities. So these things give an inherent risk that you're on the internet. You could do one of these things by mistake. Education is key here. We want to make people aware. Be careful of what you open in your emails. Be sure that you trust it. Be sure that you use antivirus software. Be aware of the address of the page you're going to prevent phishing attacks. Ensure that you have the right configuration settings set on your computer. These are things that help protect you. They're the firewall plays the role of the condom, and then you can do some additional protection to try to reduce that risk closer and closer to zero. Never actually reaching zero, but getting closer and closer to zero. Now, this is much, much different than when you have no firewall. This would be like sex without any condom or a condom that has holes punched in it. What happens here is the users now don't have to make any mistakes on the internal network. The bad guy just walks through your front door because there's literally a hole there for them to do that. It also means that the hacker can continuously send ongoing hack attempts to that open machine, which must eventually succeed given enough time and effort. So it's a much more increased active risk uh, not using any firewall or having holes punched in your firewall. So you want to be very careful about that. Now, one common thing that I see that is a really, really bad idea, red alert, is this idea of, okay, so I have this configuration that I've shown you earlier. I have this web server. As I said, the web server cannot access the internal network. The internet cannot access the internal network. They're all protected by the firewall. Everything is well and good. And then somebody says, well, wait a minute. I have some secure files back here on my network, and I want to be able to share them through the web server to the public. So what they'll do is they'll punch a hole and they'll say, well, I'm going to put a hole in the firewall so just this web server can access files on this computer. The internet can't do it, but just this web server. And they're like, so I'm safe because I kind of trust this web server. And that's the problem. Devices here are way more risky and untrusted than devices that are over here on this side of the firewall on your private network. So what happens here is the bad guy in the internet is constantly trying to attack your web server. And they can because there's no firewall protecting it. So boom, 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 boom. And remember, this is like I said, this is like sex without a condom. So eventually they're going to win. They're going to get in, they're going to have access, they're going to get access to this machine. Now that they have access to this machine, they can then find this open hole and continually attacking your private network over and over and over again through this hole that you made available. So you think, oh, but my data is safe. It's not really. It's just one more step after the hacker attacks this machine. This machine has access to these machines, and then he can continue using that hole in the condom to go ahead and eventually attack these machines. So very bad idea. Never, ever, ever, ever do this. It's just a mistake. So somebody says, well, wait a minute though, but I have top secret data. I don't want people to see it. So how am I going to protect it? So I'm going to show you that. So again, back to this configuration, you have your web server. Your web server cannot talk to any of these machines back here directly. The internet cannot talk to any of these machines back directly. But over here, you have some data that you want to be able to share, or you want to be able to capture some data here, and you want to be able to store it back here so nobody can see it. So what your application is going to do on your web server, it's going to encrypt that data temporarily, and it's going to store it on the web server. And every so often, this server over here, remember, all these machines here can easily access machines on the internet. There's nothing stopping the data from going this way. So it's going to make a connection to the web server. It's going to say, give me all that encrypted data. The web server is going to say, okay. And it's going to send that encrypted data back to your computer. And then it can even delete it. This machine can tell this machine, give me all your encrypted data, then delete the data. What does that mean? Okay, so bad guy attacker is on this machine here, goes in, attacks your web server, gets into your web server, may be able to see a small amount of encrypted data within the last few minutes that was recorded, maybe can steal that, but then has the problem of how do they decrypt it and see what it says. However, what they can't do is they cannot never from this machine go in and access your machines here because there's no hole in the firewall. They're stuck. They can't get any further. So they can do more weird, bad stuff on your web server. They could see possibly some encrypted data, not the whole set of encrypted data because it's getting pulled off, let's say every 5 minutes, every 10 minutes into these machines, keeping it safe. So that's how you keep your data safe in this network, not by putting a hole in the firewall, but by simply allowing these machines to tunnel into this machine to get its data, to delete the data, and to bring it back. So that's the best method to use there rather than having a hole in your firewall. Again, there's no guarantees in life. Being back here behind a firewall is equivalent to that sort of having sex with a condom. Still risky, but not as risky. Once you start putting holes in your firewall, you're almost rendering your firewall completely useless. The only time that you might want to do that is if you want to have a virtual private network or a secure tunneling network that allows you to basically put your machine back here in a safe place behind the firewall using the tunneling protocol. And that protocol must encrypt your data and authenticate you as the user, do both in order to be safe and secure. So that's the end of my presentation. Please stay safe out there.